our next experiment, that is to perform the compaction test of soil using the Standard Proctor Test. So in this test, our main objective is to determine the optimum moisture content and to determine the maximum dry density of the soil. So the apparatus which we require are the cylindrical mold, hammer having weight of 2.6 kg, mold accessories which are used to determine the moisture content, Indian standard sieves of 4.75 mm, and a balance along with the oven. So here are mold which will contain the soil, and it consists of a collar which is used to make the sample more plain at the top surface. Along with it, we are having the hammer which weighs to 2.6 kg, and when raised, it has a height of fall of 31 centimeters. Here in the pictorial view, we are going to see that this is the soil which is filled in the first layer, and this hammer which is to be placed on this layer and will give it 25 number of blows. This whole mold has to be filled in 3 number of equal layers. So showing here the first layer, the 25 number of blows will be given. Similarly for the second and the third. Now coming to the observation part, we are going to find the weight of mold plus weight of soil for the different observations with varying water contents, and weight of mold that will nearly be same in each of the case, and the soil weight will be determined by subtracting W2 minus W1. Water of content will be determined from each of the sample with the help of the oven. The density of the soil can be found out by simply using the soil weight divided by the mold weight, which is known to us as 1000 centimeter cube. The apparatus which we are going to use to do our compaction test. Here is the empty dish. This is the dish containing the soil sample along with the trowel. This is the 4.75 mm sieve which has been used to extract the soil sample. Here is the Standard Proctor Test mold and the hammer which has a height of rise of 31 centimeters. Along with it, we are having a weighing balance which is used to determine the soil weight which is to be put in this mold. So first of all, we are going to weigh this empty mold on our weighing balance. We are going to put the soil sample in our mold. This soil sample has to be filled in 3 equal layers, and each layer has to be compacted by using the standard hammer and by giving it 25 number of blows. While giving the number of blows, we will have to move this hammer along with the compaction by giving like 25 number of blows and moving it around the mold. So now we have filled this mold in 3 layers using our hammer and giving it 25 number of blows at each layer. Now we are going to remove the collar part, and we are going to make it a plane by using the spatula and other instruments. So on making it a plain surface at the top, we are going to now weigh it. Before weighing it, we must remove the extra part of soil which has been attached to our mold. This extra part can be removed. After this, we are going to weigh our soil sample on our weighing balance. Now, by subtracting the previous reading, that was the empty mold reading, we can find the weight of soil which has been placed in this mold. As we had determined the value of the density for this soil, we are also going to find the value of water content corresponding to which we have determined the density of the soil. For that, we are going to extract a small amount of sample from this soil and we are going to place that sample in the oven, and that will help to determine the water content. We are going to weigh this sample. The empty weight has been found as 20 grams. So now, as we have done the experiment in our lab, now we are going to see our observation table and plot those values here. So first is the weight of empty mold, that is 4810 grams and remains same. In the next we are having weight of mold plus the soil weight and it is getting changed. Next, the weight of soil that will be obtained as W2 minus W1. Similarly, the water content we had obtained from our lab using the oven. Now, the bulk density of the soil can be found by simply using the density is equal to mass by volume formula. Here the mass is obtained and the volume is known to us 1000 centimeter cube. So the density of the soil has been found here. For the dry density, we can use the formula as gamma dry is equal to gamma bulk upon 1 plus water content. So using that formula, I had found the values of dry density here. Now coming to our graph, plotting those values of dry density versus the water content, we had obtained this graph using the most probable curve. I had plotted this graph. From this graph, we can obtain the value of maximum dry density, which is at the uppermost point of this graph, that comes out to be 1.95 gram per centimeter cube. Now the water content is 11.2, which corresponds to the value of 1.95. So now this means that this soil sample will give us the maximum dry density at 11.2% addition of water content. So here our experiment ends. The results are optimum moisture content is 11.25 and the maximum dry density are 1.95 gram per centimeter.